This is Alaknanda, a massive grand design spiral galaxy located 12 billion light-years from Earth. At first glance, it looks ordinary, beautiful but ordinary. But here's what makes it extraordinary. We're seeing it as it existed just 1.5 billion years after the Big Bang. According to everything astronomers thought they knew, this galaxy should not exist. In the early universe, galaxies were supposed to be messy, chaotic, clumpy collections of gas and stars still finding their shape. But Alaknanda looks like it belongs in the modern universe, alongside galaxies billions of years older. It has two sweeping spiral arms wrapped around a bright, round central region. It's organized, it's mature, and it's breaking all the rules. In late 2025, two astronomers from the National Center for Radio Astrophysics in Pune, India, Rashi Jain and Yogesh Wadadekar, were studying images from the James Webb Space Telescope. They were examining data from 21 different filters, dissecting light from the early universe. And then they found something that made them stop. A galaxy so perfectly formed, so unexpectedly mature, that it challenged everything they thought they knew about cosmic history. Rashi Jain and Yogesh Wadadekar spend their days studying the cosmos from Pune, India. Using the most powerful space telescope ever built, the James Webb Space Telescope, they were peering back in time, hoping to understand how galaxies formed in the universe's infancy. What they found would make headlines around the world. The James Webb Space Telescope is uniquely powerful. Its infrared vision allows it to see through cosmic dust and look further back in time than any telescope before. For their study, Jain and Wadadekar used 21 different filters, each one capturing a different wavelength of light. Together, these images would reveal the true nature of a galaxy from the dawn of time. They named it Alaknanda, after the Himalayan river that serves as one of the headstreams of the sacred Ganga. Why this name? Because the Alaknanda River is the sister of the Mandakini, and Mandakini is the Hindi name for our own Milky Way galaxy. Just as the rivers are connected in the mountains, this distant spiral is connected to our cosmic home. A poetic name for a poetic discovery. Alaknanda lies at a redshift of about 4, meaning its light has been traveling for more than 12 billion years to reach us. We are seeing this galaxy as it appeared just 1.5 billion years after the Big Bang. The universe was only 10% of its current age, and yet here was a galaxy that looked remarkably similar to our own Milky Way, which is 10 billion years older.
Alaknanda is not a small galaxy. It spans about 32,500 light-years across, roughly one-third the size of the Milky Way. For a galaxy that existed when the universe was in its infancy, this is enormous. Most galaxies from this era were small, irregular, and still forming. Alaknanda was already grown up. The galaxy contains roughly 10 billion times the mass of our sun and stars. That's 10 billion stars, already formed, already organized into a beautiful spiral structure. To have assembled this many stars in just 1.5 billion years is astonishing. The universe simply hadn't been around long enough, or so we thought. And Alaknanda isn't done growing. It's forming new stars at a staggering rate, about 63 times the mass of our sun every single year. Compare that to the Milky Way, which forms just 1 to 2 solar masses annually. Alaknanda was in a cosmic growth spurt, churning out stars 30 to 60 times faster than our own galaxy. Here's the puzzle. Analysis suggests that half of Alaknanda's stars formed after the universe was about 1.3 billion years old, meaning it built 5 billion solar masses of stars in just 200 million years. That's extraordinarily fast by cosmic standards. Somehow, this galaxy pulled together enormous amounts of gas and organized it into a beautiful spiral disk in an astronomically short time. To understand why Alaknanda is so surprising, we need to understand what astronomers expected to find. The traditional model said early galaxies would be chaotic, clumpy, turbulent, disordered. Gas clouds would collapse in bursts, creating galaxies too hot and unstable to form a calm, rotating disk. But Alaknanda tells a different story. Its structure is not chaotic, it's organized. Using a tool called GalFit, which models galaxies based on their light profiles, researchers confirmed it has two symmetric spiral arms, a well-formed disk, and a bright central bulge. It has the structural maturity of a galaxy billions of years older. Lead author Rashi Jain put it this way: finding such a well-organized spiral disk at this epoch tells us that the physical processes driving galaxy formation, gas accretion, disk settling, can operate far more efficiently than current models predict. It's forcing us to rethink our theoretical framework. Alaknanda is not alone. Webb has found other galaxies that are too mature, too early. But Alaknanda is one of the clearest examples of a grand design spiral from the universe's infancy. It's forcing astronomers to go back to the drawing board, so how did it form its beautiful spiral arms so quickly? Astronomers have a few ideas. First possibility, interaction. Researchers noticed a small spheroid galaxy nearby, a possible companion. When galaxies pass close, gravity can trigger spiral arms. The problem? Arms formed this way usually fade quickly. Alaknanda's arms are clear, prominent, and permanent looking. Second possibility, clump dissolution. Early galaxies were often clumpy regions of intense star formation. As these clumps dissolve over time, they might redistribute gas into spiral patterns faster than we thought. Alaknanda could have evolved from a clumpy mess into this beautiful organized state in record time. To find the real answer, we need more data. Astronomers plan to use ALMA, the Atacama Large Millimeter-Submillimeter Array in Chile. By measuring how fast Alaknanda is rotating and whether its disk is cold and orderly or hot and turbulent, they can finally determine which story is true. Alaknanda is more than just a beautiful discovery. It's a sign that our understanding of the early universe needs to evolve. Galaxy formation models will have to address how such large, luminous, and organized galaxies could exist so early in cosmic history. The early universe was not the simple, chaotic place we imagine. This is the James Webb Space Telescope revolution. Since it began operations, Webb has repeatedly surprised us finding fully formed galaxies earlier than expected, black holes that grew too fast, and now, a grand design spiral from the universe's infancy. Each discovery forces us to ask new questions. On Earth, the Alaknanda River has flowed for millennia, carving valleys, sustaining life. In space, the Alaknanda galaxy has spun for billions of years, creating stars, building worlds. Both are named for the same thing, the eternal flow of existence, the beauty of creation. Two astronomers in Pune, India, looked at data from a telescope orbiting 1 million miles from Earth. They saw light that had traveled for 12 billion years. And in that ancient light, they found a galaxy that challenges everything we know. This is what discovery looks like. This is what it means to be human. Alaknanda is one galaxy among billions. But it tells us something profound. The universe is richer, stranger, and more wonderful than we ever imagined. As new telescopes come online, we will keep discovering and keep being surprised. Because the cosmos never stops teaching us, we just have to keep looking up.